Hello again, students. This is a great lesson today. We're learning about inequalities, and we're going to start recycling a lot of the skills we learned. But first, we have to learn how to graph our solutions for inequalities, which you have seen a little of in your sixth grade standards. When I ask you to pause, you are actually going to copy down this whole standard here because this is the first time it's showing up on Note all by itself. So please write down the full standard. I'm going to have you pause right now. Okay, welcome back. I did forget to mention to copy everything you see. So if you didn't catch that part, you may want to pause one more time to copy everything you see. And we're going to move on. So essential question today is how do we write and graph our inequalities? So really this whole focus of this lesson is to show a solution to an inequality problem. So we have the different inequality symbols. We have our less than symbol. We have our greater than symbol. We also have our less than or equal to symbol and our greater than or equal to symbol. And then this last one that doesn't happen often, the does not equal. And if you ever have trouble remembering the less than or the greater than names, I was lucky to be taught this by a teacher in my past. Everyone knows how to draw a line, and remember a line has to have arrows on it. And smaller numbers are always on the left side, and it turns out that's the less than symbol. And bigger numbers are always on the right side, and it turns out that's the greater than symbol. Makes it way easier to remember. So then we have our common phrases for these words. Remember, it's not really possible for me to give you every phrase, but those are the common ones. And we're going to learn that less than and greater than without that line underneath it uses a circle that is, we're going to call the verbiage is used open. So when we draw it on a number line, we're going to put open circles when it's this case. And if it has this little line below it here, that's half an equal sign. That's why it has that or equal to part. And in those cases, we have to use filled in circles, or the terminology is closed. So we fill them in, or they're closed. And we're going to see how that true-false analysis helps in this lesson as well. The does not equal sign is open circle. Okay, so the first part of this lesson is we're going to start translating equations, but I'm going to go 2 slides over so you can copy both of these down for me. And pause right now for me to copy this down. Okay, welcome back. Hopefully you're noticing these chunks, these little squiggly lines here that are chunking our information. So we're going to start first on translating some inequalities. And it turns out we can do most of these from left to right, just like all of our other translations. I hope we're learning these are similar. So you, we don't know who you actually are, so we're just going to say y, you, must be at least. So go check your chart over there on the left, the table. At least has to be which verbiage? Do you see at least in there? Yeah, we do. That's going to be the greater than or equal to symbol. So y is greater than or equal to, and then we have our number of 18. That's the inequality. So in problem 2, we have the child. We don't know which child it is, so we're going to write C. Must be less than. Now this is not a subtraction less than. This is an inequality expression, so where's less than? And it's that less than symbol, exactly as it said. So is less than 48. That's our answer. And then we have geo, and we don't know who geo is, but he's going to be our variable. Sent no more than. Which one in the table do we have to use for no more than? It looks like it's going to be that less than or equal to. Notice I'm modeling how we go back to the table to check to see what the words mean. So it has to be less than or equal to 35, because that number showed up there. Okay, so that's how we're going to translate these simple inequalities. We're going to learn how to translate more complex ones in our future. So now moving on to how we graph the solution to an inequality on a number line. The inference here that I am implying, I think you all know, is how to draw a number line. Just in case you forgot, it is a line, and we put arrows on both sides. And in our number line, we're going to keep it simple. We're going to have locations for 3 different numbers. And this is that chance for so many students. When I start to ask them, place an open or closed circle on the number, they love to choose their favorite number. They love to scream 0 at me. They love to scream 1 at me. But this is not an opportunity for you to use those favorite numbers or zeros or ones. What number is the only number expressed in this inequality right here? Negative 14. So that is the number that has to show up on this number line. It has to be there. It's in our inequality expression. So what number is bigger than negative 14? That's negative 13. And what number is smaller than negative 14? That's negative 15. And really, it doesn't matter which numbers you place on that number line, as long as they're correct. But mathematicians do like to make sure that these numbers are equidistant from each other. So we went up 1 and down 1 to get those, just so you understand. Equidistance means equal distance. So it says place an open or closed circle on the number line. Based on our inequality symbol, we need an open circle. Okay, so we got that far. Step 2 is actually the part that students have trouble with. They love to graph these things based on the arrow pointing. And in this problem, based on the arrow pointing, we think we're supposed to shade the left. But it's actually based on whether or not you end up on which side gets you a true or false statement. You do not ever have to find both sides of this. You only have to find one side, because just like a 50-50 bet or flipping a coin, it's going to land on one side or the other. So we have negative 14 is less than, and instead of where the x would be, we're just going to put some empty parentheses. We're going to substitute a value into that x's location, where if it was on the left side, we put it on the left side, but since in this problem it's in the right, we're going to substitute on the right. And we're going to place a number on there, and it doesn't matter whether you choose negative 15 or negative 13. Doesn't matter at all. So let's just choose the first one we see, negative 15. What does matter is finding out whether the statement we've made is true or it's false. So is negative 14 less than negative 15? Is that true or is that false? Yeah, that's false. So we're going to put a little F under negative 15, keep our mental reminder there. And step 3 says shade the true side. So if the negative 15 side is false, the negative 13 side has to be true. Please realize I'm shading that line in, and then I'm shading that arrow because it does go on forever in this direction. And this is how you show the solution to an inequality on a number line. If you have any questions, please use that question column there. And what this reflection question on the left is asking us to focus on is none of these steps work if the variable's not by itself. And that's what the next lesson focuses us on, is how to get the variable by itself in inequalities. So again, if you have any questions, use these question columns and ask in class. Please do. I'll talk to you later.